Okay, to make sure that you more understand about this topic, let's discuss about a few examples. Okay, you may refer to this whiteboard here. Okay, okay, even the this one is called Microsoft Whiteboard. I just change the setting. Now the background become white, so it's I'm sorry, the background become black, so it's look like your old. I don't know whether you have seen one before. Okay, during my time I learned using a blackboard. It's not a whiteboard. Okay, so that's why I changed it into blackboard, so it's better to see. If the background is black, then the word is white, so it's actually protect your eyes, okay, to seeing a lot of videos, lectures of nowadays. Okay, example 1. Given the following grayscale image, okay, this is the image. Giving the following grayscale image, find the 1 intensity level resolution, 2 spatial resolution, and 3 the memory size required to store this image. What is meant by number 3 is that what are the size, the memory size that required for you to save this image inside your, for example, your hard disk. Okay, the memory size required to store this image. Okay, if you having this kind of questions, okay, if you see here, given the following grayscale image, since I don't, okay, of course, if you talk about the grayscale, like I said before, intensity level resolution can be vary. Okay, it can be 4 bit per pixels, let's say 16 bit per pixels, 8 bit per pixel, or let's say you can also have many bits per pixels. But if the question does not mention the intensity resolution, how many bit per pixels, then you should assume that they are using a default intensity level resolution for grayscale image. Okay, what is the default intensity level resolution? Okay, it should be, okay, this one should be, let's see, I am using, let's see, um, I use different colors there. Okay, intensity level, since in the question there's no, it's not mentioned what is the intensity level resolution, but you know the image is a grayscale image, so you just said, okay, since there's no, because these are not mentioned there, then you can set it by default, it should be 8 bit per pixels. Okay, that is one way to identify the intensity level resolution. If the question does not mention in the first line there what is the size, then you just use the default value. Okay, that is one indicator. Second indicator you can use is that by looking at this point here, you can see that the numbers there is 60, 100, 01. So since the range of this number, the value that inside this metric element is around from 0 to 100 something, meaning that if you are using 8 bit, so 8 bit should be from 0 to 255. So meaning that this number, okay, this number is possible to put in this range. So now it's logic to have intensity level resolution equal to 8 bits, because this number can be stored if you are having intensity level resolution of 8 bit per pixels. Okay, so how about a spatial resolution? How to find the spatial resolution? Again, the spatial resolution is number of pixels. So how many pixels here? It's 2 here, over here it's 2 over here, so it means that 2 times 2. So intensity level resolution, spatial resolution is 2 times 2 pixels, or equal to 4 pixels. Okay, that is spatial resolution. Intensity is about the ranging of color, or the level of color. The spatial resolution is about how many blocks, or how many square there, how many pixels there. Okay, then the last part, which is number 3, what is the memory size to store the image? To know the memory size, is that, okay, the memory size, okay, I just put size there. Size is equal to the intensity level resolution. Can I use the short form there? I just put IR there. Intensity level resolution times the spatial resolution SR. Okay, intensity level resolution times the spatial resolution. So meaning that it's equal to 8 bit per pixel over there. Let's bit per pixels time your 4 pixels. So if you cancel this one, then you get 36 bits. Okay, that is the size. Okay, sorry, 32. Sorry, I just have a cut. Yeah, 32 bits. Okay, at 8 times 4 is 32 bits. Okay, so that is the memory size required to store this image. Or in other words, you can also do something like this, because bit is something not very common to be used in the computer. We can see there. Okay, size. Let me size. Okay, we know that the intensity level resolution is equal to 8 bits per pixels. Okay, and again, if you learn in electronic digits, okay, 8 bits is equal to 1 byte, isn't it? So now back to our case, intensity level resolution. Our intensity level resolution is 8 bit per pixel. So meaning that if I convert it into byte, actually is 1 byte per pixels. So if you talk about the size of our image over here, the size is equal to IR times SR. So if you are using the IR in the unit of byte, actually is 1 byte per pixels time 4 pixels there. So it's equal to, you cancel this one, now it becomes 4 byte. Okay, so meaning that again, by default, if you talk about the grayscale image, the one that by default that's saved in your computer is in term of the intensity level resolution is 8 bit per pixel, or in other words, it's also equal to 1 byte per pixels, the one that's stored in the computer by default. So if you having a special resolution of 1, 2, 3, 4, means that you acquired 4 byte to store that image. Okay, this one, when we talk about the grayscale image, a default grayscale image that's saved in your computer. Okay, so if you save something which is 4 pixels, then you need 4 byte of memory space. Okay, before we go to the example number 2, I would like to further extend this example. Okay, this one is 4 pixels. Again, like I mentioned or I discussed in the previous video lecture, imagine that nowadays digital camera, you can have how many special resolution? You can have, for examples, 40 megapixels camera. So 40 megapixel camera, if you just don't focus on color image, you just focus on grayscale image, assume that digital camera can save or can convert your color image into grayscale image, and then save that grayscale image inside your SD card. Okay, your SD card, which is your memory. So one pictures, okay, you have this resolution 40 megapixel, meaning that the memory size that you need inside your SD card is actually how many? 40 megabyte. Okay, if you talk about the intensity level resolution is 8 bit per pixel or 1 byte per pixels, but by default this is the intensity level resolution that you have in your computer or in your digital worlds. So one single image of 40 megapixel required 40 megabyte. But did you realize, or do you realize, that when you capture one image, doesn't matter is it a color or grayscale, your image is not more than 1 megabyte. It can be just 100 kilobytes, 600 kilobyte, regardless. If you're having your, let's say some higher resolution camera, you can, you know, like this one, which is 40 megapixel. When you capture and when it's saved in the SD card, it's not 40 megabyte, but it's just less than 1 megabyte. Might be 100 kilobyte, or might be you know, 100 maybe 800 kilobyte, which is less than 1 byte. But when you, okay, technically when you calculate, it should not smaller. It should be like the number should be similar to the spatial resolution size. If you capture 40 megapixels, then the size should be 40 megabyte inside your SD card, but that is not happen. So why is this happen? It's because, okay, this one I just want you to think about. There's something that you are not realize, and the one that we don't cover in our curriculum, which is, okay, the one that you don't cover in your curriculum, if you refer to the first lecture notes, which is this one, image compression. Okay, that's why if you realize, if you check your digital camera, when you capture some image, the image is saved in JPEG format, and JPEG is one of the what we call as a lossy compression format, means that it's not the actual size. JPEG have been compressed. That's why doesn't matter how many megapixel, okay, when you save that image in SD card, you will see that the size is less than that. It's not 40 megapixel. If you talk about it's not 40 megabyte, because even if you capture the image which is 40 megapixels, that is because JPEG is a format which is what we call as a lossy compression, where it will compress the actual size. That's why it become a very small size. Okay, it's not 40 megabyte anymore. But let's say you take that image, you save in, let's say, in bitmap format, bitmap, okay, bitmap or b.bmp, and then you realize that that image will have almost similar, okay, it's close, I can consider as the size is almost similar with the size of the megapixel. If you save 40 megapixel, you will get 40 megabyte. Okay, but if you save in JPEG, it become less than that. That is because of compression that we not cover in this curriculum. But in reality, if you calculate in technically, if you calculate, that is the size that you that required by the memory size that required to store the image, or meanings that, okay, and then just remind, in our syllabus we don't consider any compression mechanism. So that's why when the question asks calculate the memory size, you are calculating the actual size, okay, the one that is not compressed, the image which is not compressed. So that's why if you are talking about 40 megapixels, and then the intensity level resolution is 1 byte per pixel or 8 bit per pixels, then the size is 40 megabyte. Okay, when you calculate, okay, that is because of when you are using the same formula, intensity resolution time spatial resolution.